so we want to do 7.3 number 49. It says we need to construct a quadratic equation with solutions x is 3 plus root 5 over 2 and x is 3 minus root 5 over 2. Show of hands for panic on this one. It's probably an understandable reaction. This isn't really something I had kind of prepared for, right? I have to like think a little bit, which is terrifying. Okay, so let's see if we can get to a place where we're thinking a little bit. First things first, what's a quadratic equation? Ax squared plus bx plus c equals 0, right? Okay. So this is what they want me to write, or something similar, right? And they told me it should have solutions this, right? Okay, let me rephrase my solutions in a way that might look more reasonable. If I said they wanted solutions that were x was 3 plus or minus root 5 over 2, would that more closely resemble the thing that I'm going to get out of that? Yeah, seems like. Okay, so one way I could do this is I could try to reverse engineer from the quadratic formula. Yeah, okay, so let's think that way. Let's see, so if I'm supposed to get this, and I'm really looking at this and I'm thinking this is negative b plus or minus, you guys know this thing?
Yes. Square root of b squared 4ac over 2a.
Okay, so if I'm looking at this and thinking about this, what have I figured out?
A has to be 1.
Okay.
Or could be 1.
So I might think to myself, okay, out of this business, right? A has to be 1. Well,
Could be.
maybe A doesn't have to be 1, but it certainly could be 1, right? Maybe they did some reduction to get from here to here. I'm going to go with they didn't do any reduction. Okay, so I'm just going to assume A is 1. What else do I know about? What other pieces have to match?
B is minus 3.
Oh yeah, negative b has to be minus 3, right? That really tells me that b has to be minus 3. You see that? Or at least minus 3 jives with this idea. I keep using this has to be, but that's not really true. Minus 3 works, right? What else would work?
C being 1.
Okay, convince me.
Since b is now going to be 9, and you're going to get square root of 5 from it, if you multiply negative 4 times 1, you'll get 4, getting you 5.
Did any of you catch that?
Here's a calculator.
Okay.
No, I didn't even calculate it.
What he's thinking is he's looking at this piece, right? And he's saying b squared minus 4ac, this thing we call the discriminant, right? Has to be 5, right? He just matched the 3 pieces, you know. 3 had to be minus b, 2 had to be 2a, and 5 had to be this thing, right? And then he said, oh wait, we already know some stuff. So if 5 has to be b squared minus 4ac, right? I already know some of these things. Right? This guy's going to have to go in for b. This guy's going to have to go in for a. Right? And so I'm going to find out that 5 has to be, what's negative 3 squared? 9 minus 4 times 1 times c, right? You guys see that? And then we should solve for c, right? You guys see that? So if I'm going to solve for c, I'm going to I'm going to combine some like terms and subtract 9, right? So I'm going to get negative 4 is 4c. Right? What's that dork up? You see it?
Subtracting 9.
Yeah, I subtract 9 from both sides, so that gets rid of this. Makes this a negative 4.
Negative 4 equals negative 4c.
But I lost a negative here. So really I should have gotten negative 4 is negative 4c. You guys see that? That's this whole business, right? Is negative 4c.
Oh, right.
Then I subtract 9 from both sides. And then what do I do with this to get c by itself?
Divide by negative 4.
Okay, we divide by negative 4, so we get c is
1.
1. Okay, see that? Okay, so then I could stick all of this information into my original form here, right? So I'd get, okay, what? What do I get?
X.
X squared, right? A was 1 from here. Then what do I know about B?
Minus 3x.
3x.
Oh, B's minus 3, so I got minus 3x
Plus 1.
Plus 1
plus 1
equals 0.
equals 0. You guys all see that? Really the kind of, the thing we thought, right, was we looked at this piece, and that had to match this piece. This piece had to match that piece. And this guy had to match that guy. This is really just a pattern matching thing. Finding C got a little bit hard because I had A and B playing in there already, right? The other thing you could do with this is you could uncomplete the square. That would also work. You guys want to see that way, or you want to just go with this?
See that?
Show of hands for C that way? Okay, cool. Let's uncomplete the square. So, same thing, same setup. Right, I want to find a quadratic equation with solutions. X is plus or minus, sorry, X is 3 halves plus or minus root 5 halves. You see that?
Yeah.
So I did one more step there, right? I thought, instead of this guy, I thought X is 3 halves plus or minus root 5 halves. You guys see why I thought that way? If I was going to unextract roots, how would I do that?
Multiply 2 to both sides.
Does that make sense? When I'm running extraction of roots, right, I've got X like plus a number squared is question mark. Then the first thing I do is square root both sides. Right? I do square root both sides. So I get to X plus a number is a question mark with a square root and a plus or minus. And then what's the next thing I do?
Subtract that number.
Yeah, I move the number over, right?
So then you would add 3 halves.
Yeah, so on this we're just going to go exactly backwards, right? So the first thing we're going to do is move the number over.
Subtract 3 halves.
So we're going to subtract 3 halves from both sides. So I got X minus 3 halves is plus or minus the square root of 5 over 2. Then what?
Square both sides.
Yeah, then we're going to square both sides, right? So we're unsubtracting or unadding, right? And then we're unsquare rooting, squaring. So we're going to square both sides. So I'm going to get X minus 3 halves
On square.
all squares, good, is
Plus or minus 5 over 2. Or
5 over 4.
5 over 4. You guys all see that?
Yeah.
Yes.
That's really thinking to myself, root 5 halves times root 5 halves.
Yeah.
Right? Squaring both sides. Where'd the plus or minus go?
Should stay
Mm,
no.
When you squared it, you just
When I squared it, right, either it was positive, in which case it was a positive times a positive, or it was negative, in which case it was a negative times a negative. Either way, the result is positive, right? That's really where that plus or minus came from. We lost that. You guys see that? When you square something, you lose a little information about the thing you put in. You lose whether it was positive or negative. Does that kind of make sense? All right, so I got this. Oh, that's a quadratic equation. I could be done there. If I wanted to get it back to that ax squared plus bx plus c, what would I do?
Expand the
Yeah.
binomial.
FOIL this thing out, move that over, you'll get the same thing. Or at least an equivalent quadratic equation. In this case, you'll get exactly the same thing. The leading coefficient will be 1. You guys okay with this? Okay. So this would be another answer that would also be fine. What was our other version? Just to recap. I had something like this, right?
X squared minus
Minus
3x
3x
plus 1
plus 1.
equals 0.
Minus 3x. Like this?
Yeah.
So either way, these are the same equation. There's a little bit of adding fractions and some foiling to get between one and the other. Good stuff. If you complete the square on this thing, you'll get exactly that. Cool.